So, something different for you. You've seen this in a couple of other videos, and I've been promising to do a video of its own. We're not tearing this down. I want this to go to a home where it'll be appreciated, but we'll have a look around it, because many of you watching have never looked at vacuum tube hardware. I'm not massively familiar of it, and if you're seriously into electronics, then it's a part of the history that you should probably appreciate, because a lot of terms that are used in modern electronics started with this era. So this is just a simple power supply. It's not really functionally massively different from something like this. I mean, that gives you a size comparison. And it's designed for a radio. It's a 12 volt or 2 volt or multi-voltage power supply, and we actually, unusually for something like this, have all the details for it. This is the power supply for a radio teletype machine. It dates from the early 50s, I think 52 in the case of this, and it was a method of sending text messages around military control posts and into the field. Teletype is covered elsewhere. If you are interested in teletype, then I'd suggest you pop over to Curious Marc's channel. He's got a lot of stuff done on old teletype systems, although not as old as this one. And this is just the power supply part. We have the whole thing. The other thing's behind me, and we'll have a look at that, but that's way more complicated. And let's dive into this. So let's just straighten this out more, because it's annoying me. As you can see, it's an absolutely lovely bit of kit. It's so well built and so well designed. Things like cable looming, which is not seen that commonly in equipment anymore. Everything is clearly marked as to what it is. We've got, I don't know if you can see down here, we've got valve and transformer positions, and everything is just well designed for serviceability. This is the way these things used to be done. So let's just dive in straight to the power supply section of the circuit diagrams. I will post these up, and if you like, I will put them at the end of the video. These are double-sided printed, which is messing me up a bit. So where's our power supply? That is this section. Oh, knocked you there. That will probably white out, but as I say, I will print it in and let you have a quick look at that. So that is the AC side of it. That's when we're running off AC power. And on the other side we have the DC section. So it's interesting how different problems were solved in different ways back then. So I will take these away now. What I'll do is I'll put them to one side for my reference, and I will pop the relevant bits somewhere on the screen. But let's just dive straight in and have a look at the way the AC path works. So I'll show you the front. What's the best way to do that? And what I'll do is we'll do some separate footage for the front. So we've got this, it's not dirty, that's actually a really nice metal flake paint. So on the front we've got a big cooling grill, we've got an access panel here, and as it says, it's mains voltage adjustment, which you've got up there. So as you can see, you've got loads of voltage ranges in there. You've got 2 fuses, you've even got spare fuses here. Obviously this is potentially going to be used in a situation where it's being non-working, could be quite critical. We have our AC input here. Let's just unplug this, if I can. So everything's nice big chunky toggle switches, and these older multi-pin connectors. So that would be our AC. So you bring the AC supply in there, and that goes out to your radio. And then you've got an AC power switch. You've got a proper service earth there. Or you can lift this up. This is hard to do one-handed because it's quite a spring they put on this. And we just slide that across. It says, there we go. And we've got a DC power connector here, which has obviously seen some use, and the output for radio power there, and obviously your power switch. This is essentially 2 separate power supplies rolled into one, so that's why we've got our separate connections here, and this big stop you from using both. I don't know how much is common between the two. I don't think it's an awful lot, but I don't think you can run both at the same time. And that vent gives you an idea of the amount of airflow that goes through here. So let's go back to the top. So we'll start with AC. So our AC comes in. We've got our power switch buried deep down here. And then this comes over here through this wiring loom to the back of the voltage selector, and you can see all the pins on here and our range switch. And then all of this feeds over to the primaries on this transformer. That's quite a complicated tap setup on there. And then the outputs of that transformer, which I believe are... So our outputs are up here as well with our inputs. And then on the AC side, we feed this rectifier valve here. This then provides us with a not full wave rectification, half wave rectification by the looks, and then C2, which is going to be one of the ginormous caps in here, possibly one over towards the back there. I don't want to lean over. Nope, C2 is a bunch of electrolytics attached to the chassis up here. Then feeds our regulators. Now we've got these voltage regulator devices here. Let's just plug it in. Word of warning for working on valve equipment, we're not talking about 10, 15, 24 volts here. These things run on hundreds of volts, so you do not want to poke your fingers around here unless you have to. So we'll just wait for this to warm up. Valve equipment does need time to warm up. So you can see the filament on our diode just lighting up, and you should gradually see the purple glow of our discharge regulators there. Sorry. So these three tubes are regulators. They are in parallel, I believe. The current handling capability of these is actually fairly low, especially by modern standards devices. So they've paralleled these up to bring the current up. And that's our high voltage output done as far as that's concerned. And then we do have a selenium rectifier somewhere, which is tucked away down here. Just for safety's sake, I'm turning that off. And this is a full bridge rectifier for one of the other supply voltages. And then we've got two other AC ranges that go out as well. So in terms of functional spec here, the AC power supply is not that different from one large supply rail with a large semiconductor. Probably the closest to this would be a linear regulator, and then one unstabilized output straight off a bridge rectifier, and 3 AC outputs. Looking at this, it's quite primitive, but it did the job, and it was the best they could do at the time. And you can see we've got some massive resistors here used for various functions. Does that one actually have a part number on it? R57. So I don't know that that's part of our circuit. Nope, all of our circuits are fairly low. So your AC supply basically consists of, so the AC supply basically consists of this rectifier, the 3 voltage regulators, a couple of caps, the full wave selenium rectifier down here, the power switch, and that's pretty much it. That's all the AC power supply is doing, so it's quite simple. The rest of this is all to do with the DC supply. So let's have a look at that. It's not much more complicated, but there are more transformers and things involved, and obviously this is at play. So our DC supply comes in, and immediately it feeds this device and not much more. We've got our 2 fuses, we've got a couple of stabilizing caps, which, let's see, 56, can't see that immediately, possibly this one. So yeah, we're coming in from DC, feeding this, and then feeding this thing. Now I've covered these before. They're called Dynomotors. So we have a 12 volt or 24 volt motor in here. I think this one is definitely only specified for 12 volts. It doesn't give us that. That then is fed via a carbon pile, which is this thing here. This is a giant high current potentiometer and is designed for allowing you to adjust the speed here. So the regulation here isn't going to be wonderful. As your battery drops, the speed of this is going to drop because this is not going to compensate for any battery drop, and you'll need to deal with regulation somewhere else, which this doesn't actually seem to do. We've then got a couple of caps over that, which I think are these here, and then that feeds 12 volt out off to the radio. At this point, we are now behaving like any other power supply. So you've got a high voltage tap off here, which goes through, where are we? Let's just try and spot my chokes. They are chokes, aren't they? No, they are resistors, R58 and R59. Where are they? I can't actually see those. We've got more over here. These are L's, so L51 and L52. Where are those? There's L51, possibly. There's L51, L52. So yeah, these come straight off the generator. These feed another transformer, which is TR51. That's this one here. So we've got AC leaving here, coming onto this transformer here. This feeds another selenium rectifier stack, which I believe is on the bottom. And then that's exactly the same as the AC power supply at that point, without the regulation. So I don't know, the radio itself must do some level of regulation internally, because obviously that's going to vary depending on what's going on. There doesn't appear to be any form of feedback on there, and again we're providing a rectified and unstabilized voltage, which I'm not sure what voltage it is, it doesn't tell me. We're providing two AC voltages, one of which is center tapped. We're providing two AC voltages, and we're providing a high voltage which has two big caps across it, C53 and C54. There's C54. And I can't see C53, but it's going to be one of those two as well. And that's all there is to it. I mean, it's an enormous bit of kit for what it does, but let's just flip it over. I am obviously loath to touch anything. There's the 4K shot of the front. Yeah, I am loath to touch anything electrical. There's not really much under here. So there's our full-wave rectifier. There's the bottom of our vacuum tubes. There's C1. C1 was important. What did C1 do? C2. C1 is our stabilising cap or filter cap for the output. But yeah, that's all there is to it. It's big, clunky. There's a lot of older style passives in there, and it does the job. It just does the job in a way that's heavy and enormous, and in the case of this thing, scary loud. I have posted a video of that running. It's a bit of a pain to fire it up because none of my power supplies really have the oomph to get that spinning. So I don't really want to fire it up. It doesn't do much other than just make a scary noise, and I'll include that video clip or link it in. But it's a lovely built piece of equipment. I have this, and I have the decoder as well, the RTTY decoder as well. And if you or you know someone that would like to give this a home, preferably I would like this to go to a museum or something similar to this. And if you know anywhere, or you can put me in touch with someone that would like this, then please reach out either in the comments, or if you go to the about page for the channel, you'll find our email address there. And it would be nice, given that this is in really good condition, we have the transport cases for them as well, to see these go to a good home. So thanks for watching, take care, and see you soon.